Good morning, everyone. We are Group 5, and in this juncture, we are about to unlock one of the types of mathematics assessment. But before that, allow me to insert a short overview to clearly understand and what we are going to discuss today. Many of you wonder, what is mathematics assessment for? Is it just to test students' intellectual capacities, or to measure each of your students' learnings in every course study? For the information of everybody, mathematics assessment allows mathematics teachers in making instructional, curricular, or administrative decisions. To elaborate, mathematics assessment includes tests that will measure and assess each of our students' learning capacities instructionally. When we say instructional, curricular, or administrative, it follows standard and instructional process on assessing students' outcomes. Now, in this lesson, there are 5 types of mathematics assessment that we are about to discover. However, some of our groups already tackled the first 4 types of mathematics assessment. And now, allow our group to introduce the last type of mathematics assessment, which is the mathematics problem-solving assessment. What comes to your mind when we talk about mathematics problem-solving assessment? It is an assessment that of course assesses students' mathematics problem-solving outcomes. Now the question is, how to assess problem-solving outcome? We all know that the problem-solving measures students' critical and analytical thinking individually. Somehow, they are to show solution, particularly step-by-step solutions, and reasoning to defend and prove their answers. Am I right? So, it is a challenge to all mathematics teachers on how they are going to assess their students' problem-solving outcomes. However, it is said here that by looking at the quality of the answer, serve as the general impression of the solution, a teacher can check for correctness, proximity, and the closeness of being correct. What does it imply? It means that a problem-solving solution can be served correct if it possesses the following. First, there is the quality of the solution that will clearly prove the answer, or the general impression solution. Second, there is the closeness of being correct, or the correctness proximity. To clearly understand, try to look at this picture. In picture 1, what can you say? Does it show general impression and closeness of the answer? How about picture number 2? So by that, we can identify which deserves to obtain high and average scores. Speaking of scoring, thus this question comes to your mind. How do we score problem solving? Some of our teachers before directly give scores, right? In fact, some give 5 points if it shows clear solution and proves the answer, while some gives lower scores if it has some mistakes and could not clearly prove the answer. In that way of scoring, let me ask you, is it an instructional way, or does it follow standard and instructional process? So the answer is no. So instead of giving the scores to their solutions directly, mathematics teachers can analyze responses to problems based on scales. So to deepen and elaborate about the use of scales in assessing students' problem-solving outcome, allow me to pass the screen to our second reporter, Miss Giselle Zapanta.
Hi class! Today, I'll be discussing some parts of mathematics problem-solving assessment. And I want to begin with this quote. The essence of assessment is to understand how a student arrives at an answer, not just the answer itself. This is how teachers give marks to their students every time they have a problem-solving assessment in mathematics. It is not appropriate if the teacher automatically gives score to the answer itself without first knowing how they arrive at it. To make it accurate, the teacher provides a guide for scoring so that the students will be aware after receiving their scores. Also, it's the teacher's choice if they want to make students aware of the guide scales. In this example guide, each score will be based on a 0 score will be given if the student shows no attempt in understanding the problem and solving the problem. There is no answer or wrong answer based upon the inappropriate plan under which they answered the problem. Usually, these learners showed no interest in answering the activity that the teacher has provided. 1 will be given if the student completely misinterprets the problem in understanding the problem, partially corrects the procedure with a minor fault in solving the problem, or copies an error or answer labeled incorrectly in answering the problem. In short, she attempted to answer but did not really get the correct answer. But it depends on the teachers, their point system. If they want 4 being the lowest, they can, and 10 being the highest. For example, the teacher has prepared a set of problems as the recitation about the division of polynomial equations, which is their current topic. The teacher randomly calls students to answer on the board, but surprisingly, there is one student who doesn't show any of the things to consider in answering the problem, and one student who performs some but still lacks the needed requirements. But other students really did their best. So, the teacher decided to talk to them privately during their break time. The teacher asked each of them about their performance. The student who did not show any attempt answered that he felt pressured, which led to mental blocks, and other one said that he didn't really understand the topic. Based on the scenario, as a teacher, he or she must be open to the students, because it doesn't mean they did not answer during recitation, they will be graded automatically. No one is perfect. To be fully understood, the teacher should discuss the concept of answering and have a remediation plan for those students who fail to meet the expected outcome. Communication between the teacher and the students is definitely important to be aware of the skills for them to study rather than depending on the teacher's discussion.
Thank you, Ms. Zapanta and Ms. Ladika, for sharing your knowledge. Hello, everyone. By the way, my name is Patricia Dumangog. So, we are the assigned group for this type of assessment, the Mathematical Problem Solving Assessment. So, this type of assessment focuses on evaluating students' abilities to solve mathematical problems effectively. And instead of giving scores or just checking their solutions, an assessment is done based on specific criteria such as understanding the problem, solving the problem, and answering the problem. And this is to avoid potential biases. So, this type of assessment outline a scoring system that categorizes student performance that is based on various aspects of problem solving. The scores ranges from 0 to 3, where each score corresponds to different levels of understanding on the problem. And since Ms. Zapanta already discussed the criteria for scores 0 and 1, so I am the one who will going to discuss the criteria for scores 2 and 3. And in the criteria of understanding the problem, we will give the student a score of 2 if the student has a moderate understanding of the problem but may misinterpret a minor part of it. So, for an example, the problem is algebraic expression that involves factoring. So, in the context of assessing a student's comprehension of an algebraic expression, a score of 2 signifies if a student knows how to answer the problem or know the processes in answering but slightly misunderstands the algebraic problem that can lead to a minor error upon getting the correct solution or answer. So, just like in my personal experience last week, I experienced the same situation. I know the process of solving the problem. However,
I slightly misunderstand the problem, that is why I use the wrong way. So that is why it is very important to recognize the problem first. Next, we will give a score of 3 if the student has a complete and accurate understanding of the problem and its components. This means that the student has denoted a profound comprehension of the problem at hand. The student denotes a level of understanding that transcends the mere application of procedures, and it represents a comprehensive grasp of the problem where the student not only knows how to solve it but thoroughly comprehends its complexities. And next criteria is solving the problem. Of course, we will give a score of 2 if the student uses a mostly accurate approach to solve the problem. So for an example, during the process of solving, the student make a small mistake in one or more of the steps required to reach the solution. So this error does not significantly alter the overall correctness of the approach, but it is a minor mistake in executing the procedure correctly. And despite this minor procedural error, the student's method remains fundamentally correct and aligned with the problem solving. So, for an example, you are asked to solve the integral of 3x squared plus x. So, during the process of solving, you commit mistake in, for example, the sign. So, instead of arriving to an answer of x cubed plus x squared over 2 plus c, your answer is x cubed minus x squared over 2 plus c. So, you have done a minor error. Maybe some teachers will consider that one, and in my case, yes, of course, I will consider. Probably, I will give my student a score of 2. Next, we will give a student a score of 3 if the student provides a comprehensive plan that could lead up to a correct solution. So, the student offers a thorough strategy that has the potential to guide them to the right answer, showcasing a solid understanding of effective problem-solving approaches. So, the student's strategy is not just comprehensive, but also displays a clear grasp of the problem's complexities that showcase an ability to strategize towards the intended solution. And last criteria is answering the problem. So, we will give the student a score of 2 and 3 if the student get the precise and accurate answer that is expected for the given problem. So, this means that the student's ability to achieve the correct solution signifies competence and proficiency in problem solving. So, that is all for now, class. Thank you.
A pleasant day, sir. I am Rosemary Calacat and I am assigned to discuss on how to enhance mathematics problem-solving assessments. So the first thing to do is to create a situational problem that can motivate the students to communicate and explain their critical thinking. So in enhancing a mathematics problem-solving assessment, it involves creating an effective and meaningful evaluations such as presenting a situational problem that can motivate themselves to engage and apply the concepts of their lessons in solving that specific problem. Other than that is to provide a problem that can explain their critical thinking, which can truly measure the students' problem-solving skills and abilities. So here are the examples that can enhance the mathematics problem-solving assessment. First is to present the problem with complete facts and conditions, but have the students do these following tasks. Write the appropriate questions, solve the completed problem, and write their perceptions about their solution. First, write appropriate questions. So in presenting a problem, we have to provide questions that are clear and understandable in order for the students to comprehend the question and answer the problem appropriately. Second is to solve the completed problem. So students must solve the given problem in their preferred strategy and method in finding the accurate answer of that specific problem. Third is to write their perception about the solution. In this manner, teachers must encourage the students to reflect on their problem-solving experience, ask them to describe their thought processes and their challenges they have encountered during the problem-solving process. The second example in enhancing a mathematics problem-solving assessment is to present a problem and a partial solution, but have the students complete the solution. With this strategy, students will be able to think critically on how they are going to finish solving the problem by giving a partial solution. They can also ask themselves what they need to do just to complete the solution and arrive to the correct answer. Also, they can rationalize themselves what specific method or technique they need to use just to solve the problem and get to the final answer. So these are the examples that we can apply on enhancing problem-solving assessments. The last two examples will be discussed by Miss Eileen Pelinio. Thank you so much and good day.
The teacher will present a problem statement including additional information that is intentionally unrelated to the main problem. These unrelated facts might be distracting or misleading, but they are included to challenge students' ability to focus on the core issue and ignore irrelevant details. After presenting the problem, students are asked to express their opinions, comments, or critiques regarding the quality of the problem statement. This can involve breaking down the problem and describing the mathematical or logical operations they use. This will help students construct a similar problem, foster creativity, and allow them to apply their critical thinking skills in a novel context. These problems should be based on the same principles or concepts but may have different values, variables, or conditions. This step encourages students to apply their understanding of the problem-solving process to generate new scenarios. By implementing these strategies, you can create a mathematics problem-solving assessment that not only measures students' abilities accurately but also deepen their comprehension of problem-solving strategies and boost their creativity while reinforcing their grasp of mathematical or logical concepts.